Right now, the absolute top tier of artificial intelligence is locked behind closed doors. To get the highest level of reasoning and memory, you must route your data through massive proprietary systems owned by a handful of tech labs. But the way developers use AI is shifting. We are moving away from simple chatbots that just answer questions and leaning into autonomous coding agents. These agents need to read entire software repositories, scan thousands of log files, and execute multi-step tasks without a human holding their hand. To work independently, an agent needs an enormous memory space, what developers call a context window. And right now, those giant context windows are trapped behind proprietary paywalls. This map of the AI ecosystem shows exactly where DeepSeek is trying to strike, in the center. DeepSeek is positioning its newly released V4 Preview model directly against the proprietary networks from OpenAI, Google, and Anthropic. This slide breaks down their strategy into three clear pillars. They are offering a 1 million token context window, releasing the model weights publicly under an MIT license, and explicitly building the architecture to plug straight into coding agent workflows. DeepSeek is making an aggressive infrastructure play. They're attempting to make autonomous high-memory AI cheap and accessible enough for anyone to actually build with. This comparison table shows DeepSeek V4 is a family of mixture of experts models. The heavy-duty V4 Pol holds 1.6 trillion total parameters, activating only 49 billion to save power, alongside the lighter V4 Flash built for speed. Looking at this pricing chart, you can clearly see the deployment strategy. DeepSeek charges $1.74 per million tokens for a cache miss on the Pro model, compared to just 14 cents for the Flash version. This graphic explains what you actually get for that price. A 1 million token window means the AI can hold roughly 3,000 pages of text in its active memory at once. Instead of chunking data into tiny pieces, developers can dump entire legal case files, massive research logs, or complete software code bases into the model in a single prompt. By splitting the release into a workhorse Flash model and a high-end Pro model, DeepSeek is effectively handing enterprise-scale memory to the public, allowing developers to route easy tasks to the cheap tier and reserve the heavy computing for when it counts. Pushing 1 million tokens through an AI model creates a severe mathematical problem. In a standard architecture, making the model pay attention to every single word across thousands of pages requires so much computing power that it becomes too slow and completely unaffordable. This diagram outlines DeepSeek's hybrid attention. By preserving crucial signals using sparse attention and aggressively compressing background noise, it requires only 27% of the computing power and 10% of the memory cache compared to the previous generation. This documentation screenshot shows how the sufficiency gets used. DeepSeek's API is fully compatible with existing workflows, meaning you can plug V4 directly into tools like Claude Code and watch it execute live terminal commands in your own workspace. This benchmark slate shows how DeepSeek positions itself against proprietary software models. They report a 93.5 on live codebench and an 80.6 on real-world software issue resolution, placing them right alongside the top closed-source systems. By combining competitive coding skills with drastically reduced computing cost, V4 attempts to make autonomous self-correcting coding agents financially viable for everyday developers. Even with clever architectural upgrades, AI software is still strictly bound by the physical limits of hardware. For years, the physical infrastructure required to train and run these massive models has been heavily dominated by Western chip manufacturers like NVIDIA. DeepSeek has confirmed that D4 was successfully adapted to run on domestic Chinese architecture, specifically supernode clusters powered by Huawei Ascend chips. We have to look closely at the fine print. Being able to run a finished model on Huawei servers is an impressive deployment step, but it does not definitively prove that the entire computing pipeline required to train the model from scratch was entirely free of standard Western GPUs. Furthermore, high-end domestic compute resources remain highly constrained. These physical hardware limits are exactly why the top-tier V4 Pro model remains much more expensive and harder to access than its lightweight Flash counterpart. Still, integrating smoothly with Huawei hardware sends a powerful geopolitical signal. It shows that China's domestic software and hardware ecosystem is rapidly maturing, even if complete technological independence remains a work in progress. This graphic separates what we know from what we don't. The 1 million token context, open weights, and API compatibility are real. But in the uncertain column, the benchmark scores are currently self-reported. Sterilized lab tests are no substitute for independent validation. There is a massive practical difference between an AI that can simply hold 1 million words in its memory without crashing and an AI that can accurately reason its way through a chaotic, undocumented production code base without getting lost or hallucinating facts. This final slide captures the bottom line. DeepSeek V4 Preview is a formidable proof of concept, showing that open-weight AI is successfully breaching frontier territory. Its legacy won't be decided by benchmarks. It will be decided by its survival in messy, unscripted developer workflows over the coming months.